Okay, here's another table similar to the last one where we looked at statistics in terms of fractions or decimals to see basically who had the best statistics, who had the best ranking. So again, we're looking at James, Bryant, Wade and Anthony again. So number of free throws. So James 594 out of 762. So again, here's the fraction. Okay, there it is. Okay. Bryant 483 out of 564. Wade 590 out of 771 attempts. So again, let's move it over slightly so you can see. So these are the numbers, and of course, if I look at the fractions, I can't compare those fractions. I look at those fractions; they're crazy fractions. You know, I don't know who's got the best statistics there based on the fractions. If I had a simple fraction, say somebody had a statistic of 1 out of 2, a half, or somebody was attempting 2 out of 3, okay, so, you know, if you had 2 free throws and you made 1 of them, or 3 free throws and you made 2 of them, so, you know, 1 out of 2 or 2 out of 3, I know from that one that 2/3 is bigger than 1/2. I can see that. I mean, it's just kind of there, but I certainly can't see these fractions. Again, that's why we've got the decimals. If I was to write the half and 2/3 as decimals in my calculator, that's 0.5. My calculator for 2/3, it'll be 0.666 and go on forever, okay? So I can see there that that's bigger, 2/3 is bigger because 0.66 is bigger than 0.5. Well here, if we go back and look at the names, is that Bryant? I can see this person here definitely is the biggest one. He's got the best statistic. He's making 483 out of 564 attempts. Again, as a fraction, as a decimal, I can clearly see it, okay? So, if we look at actually some of the statements on here, down here, look at this. So look at this here. Which ratio form, in other words, did you use the fraction form or the decimal form, did you use to determine the ranking? Well, surely it's the decimal version. I can see the decimal. I can see who's got the biggest decimal. Can't see which is the biggest fraction, okay? Too hard. Crazy fractions. So, just little questions like that. And again, if you look at this 7a, you can try it yourself. Is 9 out of 15... is it as good as, say, Pat, who's doing 28 out of 40? No idea. Or Val, who's doing, what's that, 15 out of 24? You know, okay, a bit better fractions to deal with. But even then, looking at that, I'm not sure until I put it in my calculator and actually write the decimal instead. Okay? So, let's look at some other material here. Now then, right. Okay. So, have a look at this column here. Column A and column B. Okay? Now what we're saying here is we've got to match column A to column B. And looking at that, well again, you know, okay, so if I write column A as a fraction, that first one is 15 out of 25. Okay? So I look at column B and I go, is it 84 out of 100? Is it 65 out of 100? Is it 60 out of 100? Well again, I'm not sure really. I can show you some shortcuts, okay, how to deal with that. But right now all I can think to myself is, well, looks like I've converted column B to a decimal. I did that beforehand, okay? We should know that 84 out of 100 is 0.84, okay? Put it in your calculator to check. 65 out of 100, 0.65, you know, and so on. So I think to myself, okay, I've got column B sorted. Let's have a look at column A. Now, in a calculator, 15 over 25, 15 divided by 25 is 0.6. So you go, okay, so that one matches that one, okay? Because they've got the same decimal. 42 out of 60, okay, I think I put in my calculator, I think I got 0.7. You guys check. So you're going, okay, so that one goes with that one. And so on. So as long as you know what the decimal is, you can compare the two. But I'm going to show you something now here. So right now, we know that 15 out of 25, because I put the decimal there, 6.6, is the same as 60 out of 100, because they've got the same decimal, okay? Right. So that's me thinking, I'll just write them as decimals. I can prove that 15 over 25 is the same as 60 over 100 because they're both 0.6. Now watch this. Okay. Now hopefully you should know that a half equals 2/4. Alright? There's that 15 over 25 again, okay? But half equals 2/4. A half, a fraction. 2/4 is a half, isn't it? Okay? It's the same fraction. Halves, 1/2 is just the reduced version of 2/4. Right, now have a look at this. Okay, originally I had 2 as a denominator. If I double it, I will get 4. Well, if I do the same to the top, if I double 1, I should get 2, and that's why they're the same. I've multiplied the top and the bottom by 2 to go from 1/2 to 2/4. Okay, look at this one. Now we know that this is the same, it is equal, because we proved it by decimals. But look at this. How many times bigger is 125? I've multiplied by 4. Well, if I multiply the numerator by 4, okay, yes, I will get 60, okay? So that's it. So supposing I just said to you, okay, 10 out of 25, okay? What is it? Out of, I don't know, I'll put a question mark, out of 100. Okay, what is that out of 100? Okay, so you're not looking for anything here, I'm just telling you, what is that? Okay, if I've multiplied the bottom by 4, like this example here, okay, and I multiply the top by 4, then surely that question mark should be 40. So 10 over 25 is the same as 40 over 100, because I've done the same to the bottom and the same to the top. I multiplied by 4, okay? Now, let's have a look at this. I'll just erase that in the middle, okay? So now we know what it is. It's 40 over 100, okay? Now I'm going to watch this. Here it is. Here's a little trick for you. It's called cross multiplication. This is just to prove whether it's true or not, all right? Look at this, back here. What's 1 times 4? So go cross. It's 4. What's 2 times 2? It's 4. Okay, and that's why it's true. 4 equals 4, so 1/2 equals 2/4, because of the little trick called cross multiplication. Let's test it over here. Big numbers, calculator. Is 15 times 100 the same as 25 times 60? Well, 15 times 100, I'll go down the bottom here, is 1500. Okay? So in your calculators, folks, what's 25 times 60? It is 1500. Okay? And just like this one here, is 10 times 100? Well, that's 1000. Okay? Now then, what's 25 times 40? That's also 1000. Okay? So that's just you proving that these are true. It's called cross multiplication. And if I go back to wherever I was, here, so we're saying that 42 out of 60 is the same as 70 out of 100. Right, 42 out of 60 is the same as 70 out of 100. And I know that because I put it in my calculator and we got the same decimal of 0.7. Now here's the thing about this one. It's really hard for me to go from 60 to 100. Okay? If you look back here, I can go from 25 to 100. It's a nice multiplication. But 60 to 100, to prove this, I'm going, well, I don't know. Why not try the cross multiplication method? So 42 times 100, okay? 42 times 100, let's have a look at this. 42 times 100, I know, is 4200. Right, calculators, folks. What's 60 times 70? It is 4200. So really, I'm showing you kind of 3 different ways of proving that this equals this. Are you going to convert it to a decimal? Okay, that's nice and easy because it's just calculator, all right? Are you going to do this cross multiplication? Again, that one equals that one, okay? Or, a bit harder, you look at something and you go, okay, if I've gone from there to there and it's 4 times bigger, oh yes, and the top's 4 times bigger, then they're equal, okay? That's a third method. So, either change it to a decimal, nice and easy, cross multiplication, or are they equivalent fractions, all right? You know, look at this one again. I've multiplied by 2, and I've multiplied that by 2, okay? One more. 2/3 is how many? Don't know. 15ths. Okay? Well, if I've multiplied by 5 to go from 3 to 15, okay, multiply by 5. If I do the same to the top, 2 times 5 must be 10. Okay? So I'll get rid of the question mark now. So 2/3 is the same as 10/15. Again, write it as decimals if you want to check. Do the cross multiplication to check. Okay? But that's a nice way of going, oh, I can see it. That one to that one. That times bigger, it works. Okay?